Okay, class. We have already studied all the relevant compound angle or double angle formulae, specifically these ones. And इसमें से भी right now our focus for the next topic is for these two. Okay. So these two we'll be more focused on. What happens is sometimes an equation contains both sine and cosine, and it is not easy to simplify and eventually solve. Like in this one, the question says express 7 cos theta plus 24 sine theta in the form r cos theta minus alpha, where r has to be positive and where alpha has to be acute, giving the exact value of r and the value of alpha correct to 2 decimal places. Now, how do we intend to solve these questions? Again, there is no new knowledge that is required. We'll be using the knowledge that we had previously acquired by expanding or opening these compound angles. Now, what will we do? The first thing that we must do in these questions is to start from the answer. How do we do that? Okay, now observe. This is the final answer that I need. This is the final form that I need, r cos theta minus alpha. If I were to expand it, how will I expand it, class? How do I expand cos theta minus alpha? How do I expand cos A minus B? Cos theta, cos alpha, plus sin theta, sin alpha. Now, if I multiply it by r, I get r cos theta, cos alpha, plus r sin theta, sin alpha. Now, this is the final form that I need my answer in. I eventually need to find the value of r and I eventually need to find the value of alpha. Remember, r and alpha are constants. The only variable that we are dealing with is theta over here. Now, let's just compare the coefficients. If I tell you to comparing the coefficients, what is my coefficient of cos theta? What is the coefficient of cos theta that I am getting in this form? It is r cos alpha, and that should be equal to the expression that is provided in the question. The coefficient of cos theta is 7. Similarly, the coefficient of sin theta is r sin alpha, and that must be equal to 24. Is this clear till this point? So the approach is a bit new here, that we are taking the final answer or the form that you require in the final expression to be. That is where we are starting from. We open the double angle, then we compare the coefficients. Now remember, the values that we are supposed to find is alpha and r. Now there are two particular operations that we intend to do here. If I tell you that squaring and adding both the equations. Remember, this is a drill that we are just doing once. We will not always have to do it. The two equations that we have formed, can you square both of them and then add them? Yes, class, let's square both of them. What will I get? R square cos square alpha plus r square sin square alpha, which will be equal to 7 square plus 24 square. So we squared both the equations and then we added them. So the left side adds with the left side and the right side adds with the right side. Is this right, class? Now, once I take the r common, what is cos square alpha plus sin square alpha? Yes, class. What will be cos square alpha plus sin square alpha? Anyone? Yes, bachon.
Sir, it is going to be 1.
Yes, that will be 1. And we are left with just r square, which is equal to 7 square plus 24 square. So r is basically the square root of 7 square plus 24 square. Now remember, you don't always have to do this. We can easily see now that in order to find r, we'll just have to take the coefficients of cos and sine, square them up, add them, and take the under root of the entire thing. We don't always have to go through this entire drill. This is just to help you understand that how we got here. So r can be easily found by taking squares of the coefficients. In this case, it's 7 square plus 24 square, square root of the entire thing. Is this clear, class? So what is the value of r? Can anyone tell me the exact value of r?
25.
25. If it were a third, we would have left it as it is. If it was, for example, under root 30, so we would have left it as it is. Okay, class. Now, if I were to find alpha, I've already figured out r. Now I need to find alpha. So can I say dividing? Okay, if I'm calling this one equation 1 and this equation 2, so can I say dividing equation 2 by equation 1? Again, this is just a drill that we are doing once. I'll write that r sine alpha divided by r cos alpha is equals to 24 upon 7. The left side divides with the left side, the right side divides with the right side. R and R cancelled out. Sine alpha upon cos alpha is tan alpha, which is 24 upon 7. The question has already told you alpha has to be acute and in degrees. So can you tell me the value of alpha correct to 2 decimal places? Make sure a calculator is in degrees for this one.
Seventy-three point 74.
73.74. Okay, so now I can say that the entire expression can be written as 25 cos theta minus 73.74. Is this clear to everyone?
Yes, sir.
So whatever form the question tells you to bring it in, or whether it's cos or whether it's sine, you open that double angle, you compare your coefficients, and then you easily figure out the values of r and alpha. So now coming on to part 2, that is where this becomes extremely crucial and important. Is this part clear to everyone? Now this entire expression can be written in this form. Is this clear, class?
Yes, sir.
Or Sam, is this clear? Okay. So now this entire expression can be used and written in this particular form. Theta minus 73.74 is equal to 15. Can I do that?
Yes, sir.
Okay, and we already know that trigonometric equations are solved for the angles. Whatever angle we have, we solve it for the entire angle. In this particular case, the entire angle is theta minus 73.74. You need to deal it as a single angle. We did it even in AS, and we'll be doing it again. First, we need to change the range of the angle in which we are working with. We already know that the question has told us that theta degrees is in between 0 and 360 includes it. Now we are trying to work with theta minus 73.74. So if I were to subtract 73.74, I'll also have to subtract it from here. And I'll also have to subtract it from here. So eventually I'll be getting the range of my new angle as minus 73.74. And I'm
सॉरी
calling,
सर, अभी बहन
sorry, bete?
सॉरी सर, अभी बहन के फोन से ज्वाइन किया है, तो इस वजह
Okay.
से अभी भाग आ रहा है.
Nothing to worry about. We have not done anything new. Have you understood this thing? Converting the entire expression into a single sine or cos?
Yes.
Okay. So now we are trying to solve an equation using the form that we converted the previous expression into. इसको harmonics भी बोला जाता है क्योंकि it's mostly used in simple harmonic motion, these kinds of forms, तो इसलिए इसको harmonics भी कहते हैं. So what do you get? What is the range that you get for the new angle? Remember, the new angle is theta minus 73.74. You need to deal it as one single angle. So what is the range of this angle? Can you subtract 73.74 from 360 and let me know?
Negative 286.26.
No, not negative 286.26. It won't be
Yes,
negative.
subtract.
Okay.
अगर हम 73.74 को 360 से subtract करेंगे तो negative 9.
Yes. So remember, we want to subtract 73.74 from theta. So we also have to do it from 0. And we also have to do it from 360 in order to make sure that the inequality remains balanced. Now, this entire angle, theta minus 73.74, I've named it as x. In order to avoid confusion, I'll say 25 cos x is equals to 15. So cos x is 15 over 25. If you simplify this, you get it as 5 3s are 3 upon 5. Now understand one thing. We have already done it in AS level as well. We just don't go on taking cos inverse and find the angles. First, we find alpha. What is the value of alpha? Even if cos was negative, we would have kept it as positive and found our alpha. So what is the value of alpha, class? Remember, this is a different alpha from the one that we have found in the previous one. This is the base angle or the reference angle that we are finding. What is the value of alpha?
So हम cos inverse of 3.5 लेंगे तो alpha आएगा.
Obviously, we did it even in AS level, remember?
Yes, so 53.13 आ रहा है.
Sorry, 53 point.
53.13.
Now you will tell me, where will this alpha exist? We did all of this in our AS levels, and I'm reviewing and revising it so that you don't come up with the complaint that sir हमें याद नहीं and we forgotten about it. So we know all positive, sine positive, tan positive, and cos positive. Now this alpha will exist in places where cos is positive, right? Remember, this is the equation we intend to solve. This is the equation we intend to solve. And we are doing all of this to solve this particular equation. We first figure out our alpha. We see where our cos is positive, and we make our alphas over there. In this one, the alpha can either exist here and the alpha can either exist here. Now, these are the two possible positions for our alpha. Now, remember, what is the range of angles that we are dealing with? Minus 73.74 till 286.26. Now, we'll see in our particular given range, when do we encounter alpha? Alpha is, remember, 53.13. If I go in the negative cycle, will negative alpha be a part of my solution? Yes, class? Will negative alpha be a part of my solution? The value of alpha is 53.13, and the range for which I am allowed to go for x, or my angle, is minus 73.74. I could go till minus 73.74. So is negative alpha a part of my solution? Is it a part of my domain? Yes, it is. And what other values? This particular value, positive alpha, is also a part of my domain. Another value that you people might think can be a part of the solution is 360 minus alpha. But once you do that, it is out of the range of angle that you have already established. Is this clear, class? So the two values of x that we have is negative alpha, which is negative 53.13, and the other one is positive alpha, which is 53.13. Now you already know your alpha was theta minus 73.74. Once you have figured out the angle, then you find your unknown. Always remember, solve the trigonometric equations for the angles. Once you have figured out the entire angle, then you find your unknown. Your unknown is theta. Your angle is theta minus 73.74. So can you solve this and let me know the values of theta that you are getting? Is this clear, class?
Yes, sir.
Let's try to do something related to sine as well, so that we are comfortable. Okay, class, this is another question. In this one, the question asks us to convert this entire into r sine x plus alpha. What did I tell you? How do you approach this one?
Start with the answer.
Yes, start with the answer, the final form that you're supposed to land on, which is r sine x plus alpha. Open up this double angle. Let me know what do you get. R sine x plus alpha. MF19 will provide us with this double angle formula. So I'm providing it to you using this double angle. And remember that double angle or the compound angle expansion will eventually multiply with R as well. So you will get R sine x cos alpha plus R sine alpha cos x. Is this right, class?
Yes, sir.
Now compare the coefficients. What is your coefficient of sine x? R cos alpha. And what is it provided in the statement of the question? What is the coefficient of sine x?
Square root of 7.
Yes, absolutely right. It's square root of 7. What about coefficient of cos x? It is r sine alpha. And the coefficient of cos x is 2. Again, how do we find r? We square and add both of them. We'll not go into the entire hassle. And we'll just try to find r because we have already figured out a way. Square root of square root 7 squared plus 2 squared. So what is the value of r that we have?
Square root 53.
Not square root 63.
53, sir. 53.
No, it can't be 53. Carefully square this. Once you square this, it's just 7 bit. 7 plus 4 is 13. And this is an exact value. You have to leave it as it is. Is this clear, class? What about alpha? You take this equation, the sine one, and you divide it by the cos equation. So r sine alpha divided by r cos alpha is equals to 2 upon square root of 7. So tan alpha is 2 upon square root of 7. Can you tell me the value of alpha, class?
$37.1.
Question says 2 decimal places.
37, sir.
Okay, the question says 2 decimal places.
So 37.09.
Very good. Now the second part is a bit tricky when solving trigonometric equations. I've just told you the approach that you must take when solving this. Now this entire expression, Sam, is this clear, beta? You missed out on the last part, the previous question.
Yes, sir.
Okay. So now this entire expression, okay, remember now when the angle was x, here we got the variable as x, but now the variable is 2 theta. So now it will become r is square root 13 sine 2 theta plus 37.09. I've missed out on writing the answer in the next one. It was, I did not leave the answer. Square root 13 sine x plus 37.09. Yes, class. This entire thing is equal to 1. Now, what is the angle in this question? The angle is 2 theta plus 37.09. You have to deal this entire thing as a single angle because trigonometric equations are solved for the angles. So you just have the range of theta here. How do you convert this into the range of your angle? What operations do you need to conduct with theta to get the range of the angle provided in the question? I start with theta. What do I do first? This class, I multiplied by 2. I'll do it in steps so that you people understand. Then I add 37.09. $37.09,397 point. Now make this entire thing a single angle, and just to avoid confusion, give it another name. If anyone does not want to do that, it's perfectly fine. It is just to avoid confusion. Now you can write this entire thing as sine x is equals to 1 upon square root 30. Is this clear, class?
Yes, sir.
Yes, sir.
Okay, now remember, this is the part where we start with our A levels, with our trigonometry, the actual trigonometry that we have studied in AS as well. We just don't go on taking sine inverse and find the value of x. The first thing we do is find the value of alpha, which is our reference angle or base angle. Yes, class, what is the value of alpha?
$16.10.
16.10.
Yes.
एक minute. Have we done an array? Oh yes, we have. 7 plus 4 is supposed to be 11 over here. Sorry, bachcho, please make this correction. 7 plus 4 should be 11. Very silly error. Okay, now tell me the value of alpha.
17.55.
17.55. And I'm insisting on it again that this alpha is different from the alpha that we have found in the previous part. This alpha is our reference angle. Now, where will this alpha exist? Remember, this is the equation we intend to solve. Even if it had sin x agar is equal to negative bhi hota, alpha nikalte hue we don't consider the negative sign. Alpha is just the reference angle, and the negative sign tells us the quadrant where it will exist. But in this one, it's not negative. So the sign must be positive. So where will our alphas exist? In the first quadrant and in the second quadrant. So let's see the possible values of our angle now. We will say that the first possible value of x is alpha itself. That is what we believe it might be. But is this a part of our range? The range of angle that we are allowed? Is the first alpha part of our range? Our range, our angle must start from 37.09. It cannot be below 37.09. So the first alpha is not a part of our range, and hence it will not be considered. Okay, when else do we meet the alpha? This is 180 minus alpha. So 180 minus alpha. This will be in the range. And any other range, once we go the entire circle, and then we meet our alpha. Will this be a part of our range? Yes, it most definitely will be plus alpha. So these are the two values of x that we get. Can anyone tell me what are the two values of x that you have ended up with? Are these the two values that you get? Yes, class?
Yes, sir.
Okay, remember, this is just the angle that you have solved it for. You still need to find the unknown. So in place of x, can you just put 2 theta plus 37.09? And now solve for theta. Is this clear, class? You subtract 37.09 from both and then divide by 2.
Yes, sir.
So don't worry about the final answer. Your final answer will always end up in the given range as long as you obey the range of the angle that is provided in the question and consider the entire thing a single angle for which you are solving the trigonometric equation for. Is this clear, class?
Yes.
Anything that you people are unable to understand till this point?
No, sir.
So now let's try a question on your own.